Hi everyone, welcome to my YouTube channel on electrical engineering. Myself, Mr. D. Krishna, Assistant Professor, Triple Department, Anurag University, Hyderabad. In this video, I am going to present the Thevenin theorem problem for AC network. Before going to watch my video, please subscribe my channel to get more number of concepts on electrical engineering. So here we go to Thevenin theorem problem for AC network. For that, before going to take the problem, we must know the statement of Thevenin theorem for AC network. In any linear active bilateral AC network can be replaced by a simple equivalent circuit having single voltage source VTH in series with single impedance JTH. This is the equivalent circuit. Now we are going to take the problem, that is, find the Thevenin equivalent circuit of the network viewed from the terminal AB. For that, we must take the step 1, that will be remove 2 ohm resistor, set the voltage source to 0, that is short circuit the voltage source. After short circuiting that voltage source, we must redraw the circuit to calculate the ZTH. That is a step 1 we need to do. So now we are going to redraw the circuit. That circuit consisting of only inductive reactance and capacitive reactance, and we must short the voltage source and remove the 2 ohm resistor. That will be J8 and minus J6 should be there, and we must remove the 2 ohm resistor and we must short the voltage source. Now here we are going to find the ZTH. That will be the step 2. Step 2, calculation of ZTH. Calculation of ZTH. So to calculate this ZTH, we must know that J8 ohm will be Z1 and minus J6 ohm will be Z2. Therefore, Z1 is equal to J8 ohm and Z2 is equal to minus J6 ohm. Now from the network, your ZTH will be Z1 is parallel with Z2, that will be Z1 Z2 by Z1 plus Z2, that is equal to 8 at an angle 90 and 6 at an angle minus 90 by the sum of those value will be 2 at an angle 90. We are converting that value into polar form. Therefore, your ZTH will be 48 at an angle 0 by 2 at an angle 90. That will be 24 at an angle minus 90. This is the equivalent impedance of the given network, that is also called as ZTH. Therefore, ZTH is equal to 24 at an angle minus 90. Now coming to the step 3, we must calculate the VTH, that is the AC voltage source VTH. So step 3 will be calculation of VTH, that is Thevenin equivalent voltage source, that is VTH. For that, we must consider the network without load resistance, that is 2 ohm resistor. So now this will be the redraw circuit, that is AB, across AB terminal we must find the VTH, that will be minus J6 plus J8 ohm and then 10 angle 0, that is the source voltage. For this network we must apply the KVL to find the VTH. So apply KVL in mesh 1. In mesh 1 current will be I. Therefore, applying the KVL, the equation will be 10 at an angle 0, that is minus 10 at an angle 0 plus J8 into I minus J6I is equal to 0. Then 10 at angle 0 is equal to J2I. I is equal to 10 at an angle 0 by J2 ohm, convert into polar form, that J2, that is 10 at an angle 0 by 2 at an angle 90. Therefore, your I will be 5 at an angle minus 90. Now we got the current we need to find the VTH. That VTH is nothing but Z2 into I. What is a Z2 here? Minus J6 ohm. Already we mentioned in the network. So now we are going to find your VTH will be minus J6 into our current is 5 at an angle minus 90, and we convert that polar form, that will be 13 at angle minus 80 degrees, that is from J at an angle 90 into 5 at an angle minus 90. So after multiply that value, we'll get our VTH will be 30 at an angle minus 180. So this will be the VTH. Now we are going to take the step 4. That is our problem. Draw the Thevenin equivalent circuit. So if you want to draw the Thevenin equivalent circuit, we know the statement. What is the statement? VTH series with ZTH across the load impedance. So now we are going to draw the Thevenin equivalent circuit, that is VTH is series with ZTH across the load element, that is ZN. Now we want to apply the values for a given Thevenin equivalent circuit. That will be VTH, and then ZTH should be in the box because it is a complex number, ZTH, and across the load element. So here load element will be 2 ohm, and then your ZTH will be 24 at an angle minus 90, and VTH will be 30 at an angle minus 180. So this will be the Thevenin equivalent diagram, and this is a simple problem on Thevenin theorem for AC circuit. Please watch my video and subscribe my channel.